This conference will now be recorded.
Okay. So far we have discussed about abstraction. Abstraction is, as you guys said, hiding the details, hiding the implementation details, and provide the functionality. Provide the functionality. This abstraction we will achieve by using abstract classes and abstract methods. By using abstract classes and abstract methods. So the advantage of this is we can prepare a common class where we can have a common methods, common method definitions or a declarations. And when you are creating a child classes, whoever is interested, based on that, we can provide the functionality. Okay, let's take an example. If take an example like bank, or let's take an example car, or let's take an example animal, right? So based on the child classes, the common functionalities will be there, no? If you take a example of a bank, what will be the common functions? Withdraw will be there, deposit will be there, and their rate of interest will be there, type of loans will be there, right? So when you declare a bank as a abstract classes in the top level, in the child classes, we can have a different banks, correct? We can have a different banks like HDFC Bank, Citibank, ICICI Bank, SBI Bank, different banks, right? What they can do, they can actually implement the details. They can actually take the details from parent and they will implement their own. If you take HDFC, their rate of interest is different. Their loan types are different. Their withdrawal or deposits, maybe if they have charges, their charges are different. So we can provide this kind of functionality. It means we can provide um, a blueprint or a template or a common functionalities in abstract class. The child classes, they will be overridden based on their requirement. If you take animal class here, these are all common properties, behaviors, eating, running, making sound, all of these are all common. So dog, it has its own, cat, it has its own, right? Deer, it will have its own, fox, it will have its own. So the behaviors are same, but implementation details will vary. The behaviors are same, the implementation details are vary. Okay, are you guys following me what I'm trying to say? If you take a bike, model, make, year, the price, so you can take one bike, KTM, or you take a BMW, or you take a Apache, or you take a Yamaha, or whatever the bike it is. Their price varies, they make, model, year, and they perform, their power, the speed, these all will vary, right? Their mileage, and everything will vary. So they will provide their own functionality. Okay, yeah, please acknowledge me in between sometime because I'm connected to mobile. I just want to cross verify whether my connection is connected with you or not.
That is working well, fine.
Yeah, good. Okay. So similarly, how we have abstraction, there is something called trait, T-R-A-I-T, trait. Trait also exactly same as your abstraction. Trait also will help you to provide abstraction functionalities, non-abstraction functionalities. But why we need a trait? I'll explain you a simple thing, okay? Let me take one example. I have a class, employee, okay? There is something abstract class already. Hmm, let's say I'm taking bank because of bank account, okay? So this employee extends bank to get the bank functionalities. Let's assume that there is one more class, abstract or not non-abstract, whatever it is, abstract or non-abstract, whatever it is. Let's say address. Now he need address also here, so we cannot do like this by separating comma. We cannot do like this since it will not allow multiple inheritance. Since Java roots concepts will not allow multiple inheritance. Not all the OOPS concepts, Java, Scala, these things will not allow multiple inheritance with the classes. With the classes, it will not allow. So then how can I get this? Do one thing. This class, make it trait, extend address, then say with the bank. It's possible. It is possible. And you can have any number of with. You can have any number of with. Are you guys following me? Please ask me if I'm not clear. Here, your trait help us to achieve multiple inheritance, and also it also helped us to apply the other functionalities. Okay, so when you want to have a multiple parents, since directly the classes are not allowed, we will go with the traits. What is a trait? Trait is also collection of abstract or non-abstract methods. Abstract or non-abstract methods. Okay. So so to achieve the multiple inheritance, we can take a help of your trait. We can take a help of trait. Let me close others. Keep only trait. Look at here the simple example. I have a printable trait. The trait name is printable. This printable trait has one abstract method, one non-abstract method. One abstract method, one non-abstract method. Okay, and you can have one more trait. One trait can extend another trait. One trait can extend another trait. You extend how many traits you extend, how many traits or abstract classes, whatever you do, you have to provide a functionality for all the abstract methods. Try to remember, guys. You have to provide the functionality for all the abstract methods. No matter whether you have extended only one trait or two traits or only one, um, what I can say, uh, one abstract method, two abstract methods. How many abstract methods are there, including both? Including both, how many you extended? You have to provide a functionality for all of them. You have to provide the functionality for all of them. No excuse. Okay, keeping that in mind. Okay, and look at here. Here I have one print. This is one abstract method, and in the trait one we have a disp is one abstract method. Trait two, one more trait is extended trait one. So it has some implementations here. Look at here. I have a class which is demo. I have a class demo printable. Yes, you have to provide the functionality of the printable. T2. T2 since does not have any abstract as of now, but it is extended the T1. T1 has a disp. So you have to provide the implementation for the disp. Since this disp2 is a concrete method, concrete or non-abstract method, you really no need to provide. If you want, you can provide. That's up to you. If you want, you can provide. Is this clear? Is this clear to others?
Sir, whatever the uh,
Hmm.
traits we are extending, we have to definitely provide the definition, right, for those methods.
Abstract methods, not only trait. If you go with abstract class, even abstract class has the abstract methods, right? Abstract methods,
Yeah.
you suppose if you declare from the non-abstract class, if you are extending the abstract class, how many abstract methods are there? Those many things you have to provide. Let's take an example. I'll show you here. Okay, I have a abstract bank, one abstract class. Abstract class it is. Now, one more abstract is there. Okay, you can have any number of abstract class. Okay. Mm, abstract class. What I can have. Let's take a person. This person extends address. Here you have some abstract methods. Let's say address. Address, what will have the address? Normally print address will be there. It has only print address. And what else I can have? Let's say there are a couple more abstract methods. So I'm not getting at this point. 2 and 3. Let's say this person has some abstract method. Run, eat, income. So these are few abstract methods. I'm creating a normal class employee extends person. You tell me how many methods he has to provide the implementation. How many methods he has to provide the implementation?
6.
6 methods. 6 methods, correct. Why? Because 3 abstract methods from the address, 3 abstract methods from the person.
So even if we are not calling that method in the employee class, then also we have to provide the implementation.
Which one is not calling?
Let's say I'm not going to call employee.run.
No, 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 no. See, employee is a normal class. Person is
Mm-hmm.
a abstract class.
No,
These are
sorry. If
abstract
I create
methods,
an
right?
object, yeah, if I create an object of,
See, forget
uh,
about creating object and all, Rishabh. Before that
mm-hmm.
only we need to understand one thing. Whether
Yeah,
you
yeah.
create object or not, the secondary. Before that
Mm-hmm.
only, as soon as you extended the person, in this person you have 6 abstract methods.
Mm-hmm.
You have to provide implementation for all those 6 methods.
And what about
Otherwise,
this? Yeah, yeah.
otherwise,
Please. Uh,
otherwise your employee has to be abstract. So after
okay.
you provide the implementation here, after you provided implementation here, that's your wish. Whether you are calling or not, that's your wish. I'll tell you. Okay. Let's say if I open a bracket like this, it means the implementation is there. Okay. If I did like this, okay. Now this employee, let's say object demo. I have a main method here. I'm not writing everything. Let's assume that main method. Val Ravi is an employee. Okay. Equal to new employee. I have called. So now you call Ravi dot run eat whatever the method it is. That's whether you're calling or not. That's up to you. That's up to you. Following, Rishabh?
Yeah, Ravi, yeah.
So this has to be like this.
Sir, person need to extend address abstract class address methods also? Is it mandatory or not?
See, since it is abstract, since person also abstract, he really no need to provide implementation for address. He really no need to provide implementation to address. Since both are abstract, there is no point providing implementation. But whoever extends the person, he has to provide the implementation for methods of person as well as address, both. Is this clear, ma?
Yes, yes, sir.
So similarly, your traits also. Okay. Similarly, your traits also. I have a trait 1, printable is one trait 1, trait 2. If I extend a trait printable and with the trait 2, how many abstract methods are there in these two? All of them I have to provide the implementation. Otherwise, it will complain. No, you have to provide implementation for all of them. Look at here an example. I have a trait called print friend. Forget about the sealed. I'll talk about the sealed later. I have a friend. I have a the friend is one trait. So it has a name and listen. It means my friend will listen me. There is something called human class. He extend a friend. Traits can be extendable. Try to remember, guys. Traits can be extendable. So this human extended the friend and he has a method called show. Okay, and there is an animal, no extend nothing, and there is a dog and also on. So here, if I create an object for the human, I can say human is listening friend. You can call this method. Okay, so your class dog is extended the animal and with the friend. So dog is animal and also it's a friend. So we know that most of the people have the dogs and they'll treat them as like friend, like that. Very simple, very simple to make you understand. Trait also another abstraction, another abstract class. Since we cannot extend the two abstract classes, we use the traits. Traits we will use using with the class. With the class. Traits can be directly extendable. Traits can be directly extendable like this. Traits can be directly extendable like this, or traits can be used as a with. Traits can be used as a with. Traits can be used as with. Okay.
We can extend any number of abstract classes, right?
No. Only one class will extend, but with you can use any number. With a friend, with another address, like a with. So you can use with the keyword any number of times. You can use with any number of times. Extend only once. Look at here. Okay.
With is like implementation.
With is not not implementation, ma. With is means you are extending one more abstraction, nothing else. With is you are extending one more. See, as I told you earlier, I cannot do multiple extensions. Correct? Can I do multiple extensions?
No,
So if I cannot do the multiple extensions, what I need to do? I'll go with using with. Look at here an example. No, simple example I'll show you. I have one trait. It's called print. I have one trait which calls show. Which calls show. I have one class. Okay, forget about this class. Okay, don't worry about this class. I have one more abstract class, apps. It means I have three different things here. Let me do. Okay. For now, I just remove this one. Okay. Look at here. Prints, shows, apps. I have three different abstractions are there. Three different abstractions are there. Now I have a normal class employee who need all these three functionalities. Who need all these three functionalities? Is it possible? Extending, is this possible extending all these three? Extend apps,
No.
extend shows, extend, no, right? So what we will do? Extend the class, extend the abstract class like MP extends apps with prints with shows. You got my point? If you have one more also you can do. Say if you have address also one more. Abstract class only one. Abstract class can be only one. That's what I'm trying to say. Abstract class can be only one. So remaining all traits. Trait address with address. You're getting my point? Your extend will be always one, but with you can do any number. Any number of traits you can extend. Any number of traits you can extend.
Ravi, the order of trait classes that we are using in this line number 19 will have any
Hmm.
impact? Any impact on the implementation?
Ideally, basically, whatever the way you call it will get extended. That's it. There won't be
Mm-hmm.
any impact, but the execution will be from the rightmost, right? Always it will be from the rightmost. Address, shows, prints. The way you call it is different. So suppose in my method, employee object, I called an address first. I call shows later. I call prints later. So that's varies. Okay, you're getting my point? Look at here. If I have,
Yes.
okay, I didn't do completeness of this. If I write it, then I'll go with whatever the way I call it. So please look at this. I'll just come in a minute. Any questions, guys?
Yeah, Ravi, I have one question. Like in
Yes.
abstract, when we are extending it, all the six methods we need to implement. In the trait, it's compulsory. We should implement all the methods when we are extending it.
See, wherever you have abstract methods, just remember, wherever you have abstract methods, whether it's a trait or whether it is abstract class, the implementation class should provide functionality for all the abstract methods.
Okay. Okay.
The implementation class has to provide the implementation class has to provide the functionality for all the abstract methods, whether it's a trait, whether it's abstract class, no matter. Okay.
Okay.
Okay, ma.
Yeah.
Any other questions? Okay, so you can extend from one trait to another trait. Try to remember, this is also important. You can extend from one trait to another trait. You can extend any number of traits. You can look at here, one abstract class, one trait. One is my bank. It has its rate of interest and it has some display method. Similarly, I have one finance institute. It has its own method. So the consumer extends my bank and finance institute. He has to provide implementation for both. He has to provide implementation for both. Don't worry about these things. This is a concept I'm explaining here. So I haven't completed the examples. These are conceptual. I just want to show you how the implementation, how the override will help. So it's a override. So implementation for the rate of interest, I'm applying the I'm providing the implementation. Get loan also I'm providing implementation. Since I have both has been taken. Okay, both the parents has been taken. And also try to remember your trait can have both the methods, non-abstract, abstract. It can have both the methods. But then you may ask, then what is the difference, sir? Why I need a trait? Already I have abstract. Already I have abstract. Then why I need a trait? Your abstract can have constructor where traits cannot have a constructor. Try to remember this. Your abstract can have a constructor where traits cannot have a constructor. We cannot have a constructor in traits, but we can have a constructors in abstract classes. We cannot create object to trait as well as abstract. We cannot create object for both of them. Suppose if you try to create object like this, let's say address, val a1 address 1 equal to new address, you cannot do, it will not allow, it's not possible. Similarly, val, this is the your abstract class. You cannot do like this, not allowed. You cannot create objects for both of them. Cannot create objects for both of them. Okay. Any questions about traits? Try more examples. Try more examples. It's more important. The people will ask in interview, what is a trait? How it is different from abstract class? Trait is exactly same as abstract class. The only difference is trait cannot have a constructor. Remaining everything is same to same. Is this clear? If you guys are clear about the trait, actually I want to talk about the encapsulation and polymorphism. Encapsulation and polymorphism. But I think we have very short time to start. We can connect in the next session and we'll complete them. So with that, we will be completing OOPS concepts. Then we will start the collections. Then we'll start collections, the most important part in the Scala. By the time, if you guys, I mean, by we complete other stuff, if you can come across any questions from HDFS, Scoop, Hive on this, we will discuss about them. We'll discuss about them.
Okay, Ravi.
So that's it, guys. So
Sir, can you upload Thursday's class? Last week Thursday's class.
I uploaded, ma. I uploaded yesterday night. Please try it.
Okay.
Look at it.
Ravi, can you try and upload this before evening?
Yeah,
Like
I'll try upload
6.
this.
Yeah,
Hmm.
yeah.
Okay, guys. Bye. Bye for now. Connect in the next session tomorrow. And I'm really sorry for last 3 weeks. I know that last 3 weeks we didn't have a proper sessions because of this accident and I disturbed and this the house moving this stuff. Sorry for that.
No issues, Ravi. No issues.
Thank you.
Thanks, Ravi. Bye.